Hello, everybody. Thank you, Bruce. It's nice to be with all of you. I'm going to try and make up a little time here for everybody. Facts, performance, and technical studies really matter. Our competition cannot beat PVC pipe on facts and performance. Our competition is relying on old line engineers at the local level to force a competitor's material to be used. Our competition is also relying on the political contacts and political contributions at the local, state, and federal levels. When I go around and talk to people, I talk to them about the amount of water loss every year, 2.6 trillion gallons, and 16% of all purified water is lost every year. And the impact it has on people is incredible. They just can't understand that we're losing that much of valuable water every year. It really gets people's attention. Oh, went too far. You heard that the American Chemistry Council is working with a group on competition at certain states, and Michael Powell is going to cover that later. And you heard from Dick Doyle. They're working with the Ductile group on a comprehensive study for market opportunities and growth program for PVC pipe. So I won't go into anything on that. These are key members of the House and Senate Appropriations Committees. They're the ones that approve the money for the state revolving funds. And I just list these members here because most of these members, people in the audience and people in the industry, have visited these Senate offices and House offices during the fly-ins. So, and Bruce will be submitting testimony in March to these House and Senate committees on the state revolving funds and uses of PVC pipe and the value of PVC pipe. So when he submits that, he'll send it out to everybody, and you can contact these members of the House and Senate Appropriations Committee. And one thing, the House Appropriations Committee actually is going to pass legislation, make it all the way through. These members of Congress at committees is the Senate Environment and Public Works Committee and the House Transportation and Infrastructure Committee are going to pass what they call a WRDA bill. They're going to pass a authorizing bill this year, and we're going to want to get our open competition language in that. On the House side, I have Congressman Paul Ryan. He's now Speaker of the House, and last year during the fly-in, we had a group of people actually meet with him, and there are other members from the fly-in of our industry have met with these members. I'm going to work with you all and get our information to them on open competition. It's very important. It's a very critical time period. These independent studies, everyone has seen these studies that have been done by Bruce and independent groups. These studies are so important to give to people, put in their hands, explain to your local elected officials and your federal officials these studies. I mean, their staffs read them, and this becomes a very valuable tool for us with the information that are in these studies. I use them all the time. I walk around with a backpack full of them and hand them out on the hill to everybody, and they're really well received, and the information is great. Just no one has to remind you because of all the hoopla on the presidential, but this is an election year. You need to stay active and visible. Host a plant tour for your local officials, your state officials, your federal officials, because they love to come and meet constituents. Have a photographer there taking pictures of them, and it go in the local paper. But it really, you know, it's getting them to see constituents, but also talking about our business and what's going on. As you heard from Dick Doyle, the fly-in is September 20th to 21st. Please sign up and participate in that. It's a great time to come because Congress will be going out really for the year about the first week of October. So they'll be rushing through a lot of bills at the end, and we want to make sure we get our open competition in, you know, the bills that are going to make it all the way through. I want to thank you for your continued support and advocacy on open and fair competition. Is that okay, Bruce?
Yeah, that's awesome. Okay. like to invite Mayor Jean Marchand from, and sorry, I say it in a French way because Marchand, that's how you say it.
Nobody gets it right.
Right. And he's with the city of Livermore, and he's going to talk to you about, should we put that on? I want to put your song on, though. We got one for you. He's going to talk about water quality, different types of the middle one.
The eye of the tiger, yeah, gotta love that. Okay, water quality and PVC pipe. I spent my career, about 30 years, as a water quality chemist, so really enjoyed that. So the city of Livermore, for those of you that aren't familiar, is really a city of contrasts and superlatives. We are the oldest commercial wine region in California. We are the cutting edge of technology with Lawrence Livermore and Sandia National Laboratories. We have one of the world's fastest supercomputers, and in 2017 we will have the fastest computer in the world. We also have the world's fastest rodeo. We have the world's most powerful laser. When that laser fires, there is more energy being produced than is used across the entire United States. And we also have the world's longest continuously burning light bulb. It has been burning for 114 years continuously. It's in our fire station number 6. Livermore Wine Country, as I said, it's a beautiful location, about 85,000 people. We're located in the San Francisco Bay Area. We're about 40 miles east of San Francisco. And this, most of this talk comes from a book that I wrote called Handling Water Quality Complaints. It's by the American Water Works Association, California, Nevada section. Drinking water quality. I collected every single one of these samples. Every one of these came out of a faucet. Imagine what your constituents would think turning on a faucet and having that coming out. And I have to explain that. I get asked frequently, how did I go from chemist to politician? How did I go from legitimate work as a chemist into politics? And so very simply, the interim was I was on the Zone 7 Water Agency Board of Directors. Being a water chemist, I tested the water at my house and found that the trihalomethanes, which are suspected carcinogens, we had the national running average of about 100 parts per billion. At my house, and with my wife and my 2 children, we had 180 parts per billion, almost double the federal drinking water standard. As a water chemist, I understood that there were techniques that you could employ to treat the water so that you did not form these trihalomethanes. You could use chloramination, you could use ozone. So I ran for the water board with that knowledge, and within 6 months of being elected to the board, I changed the way the water was treated so that everyone throughout the region got water that met federal drinking water standards. Now going from the world of science, which is absolute, into the world of politics, which was quite a shift, because poly, of course, from the Latin meaning many, and ticks meaning blood-sucking parasites. Our distribution system, we've got 175 miles of potable pipe, about 18 miles of recycled pipe, most of which is PVC, almost 300 miles of sewer pipe. And for those of you, the engineers in the bunch, are saying, well, how can you have 300 miles of sewer pipe and only 180 of drinking pipe? Well, it's very simple, because what happens is we have 2 water utilities. The city of Livermore is one of the water utilities. California Water Service is a private water company, and so we split the drinking water side, the wastewater side. Livermore has all the collection and treats all the wastewater. We've got almost 3,000 valves, 1,600 hydrants, and other appurtenances. So our conversion to PVC started in the 90s. Most of our failures were old steel or cast iron pipes. Because we had corrosive soils and also cathodic protection systems had failed, you don't have those concerns with PVC pipe. I was stunned with Dave Marshke yesterday. Is he still in the audience today, Dave? Here? Okay, great. Let's have a hand for Dave here. Talk about a rough gig. Can you imagine standing in the room and telling your boss that, yes, I worked for San Diego, which was great, and then I came back to your city, which is the Stone Age. Wow, talk about. And now I'm in a good place right now because I can badmouth my previous employer because that's where I used to work, and that's where the bad practices, were all the pictures that I had taken from this talk. But where I am now, this is great because we have made a lot of these transitions. And so the useful life of the PVC pipe is comparable to what to the published lifespan. We just had a talk about how long these different pipe materials last. So here we have a whole list: cast iron, asbestos, concrete. Which in my previous employer, we had a lot of AC pipe, PVC, of course, and all the different life expectancies. The reason we started converting in the 90s is because the ease of installation, and we had found that the pipes that were failing were the cast iron, were the AC pipe, but the fact that they had 200 pipe main failures in 10 years was just breathtaking. I talked to my public works director yesterday about that, and he was glad that we're in Livermore and not in Burton. We found that the developers do prefer it. It's lighter, it's easier to install. So recognizing that, the city rewrote the standards so that it allowed for the conversion and replacement and installation of new PVC pipe. That's lighter, easier to work with, reduces costs, and of course, as the mayor of the community, costs for me are a really big deal. And we actually eventually switched to PVC on all of our internal projects. This is the miles of pipes that we have installed over the decades. As you can see, we continue to increase the potable and sewer pipes in the distribution system. This is the miles of pipe by diameter in our system. As you can see, most of it is 8 and 12. And 57% of our potable system right now is PVC. Livermore is an old city. We were incorporated, actually we were founded in 1869, incorporated in 1876. So we do have some very old pipes in the ground, but we have been switching a lot of those out. 36% is asbestos concrete, and 80% of our recycled pipe, the purple pipe, is also PVC pipe. Again, as I said, it's lighter, it's cheaper, it's non-corrosive. You don't have to worry about cathodic protection systems and improved water quality in the distribution system. It allows the city to increase the water pressure. In fact, if you recall Dave's talk yesterday, the number one goal that Burton was trying to achieve was water quality. Second was water pressure and delivery to meet the demand. So our Public Works Director, we realized that most, if not all, of our failures were old steel or cast iron pipes that had failed from corrosion due to old soil conditions or failure of cathodic protection. Since those concerns are limited with PVC, it is comparable in useful life, it made sense to make the switch on all of our internal projects, and that's my Public Works Director. So, the distribution system, maintaining the distribution system water quality. We have loop systems. Periodic main flushing is very important because you do end up building sediments up in the distribution system. We do maintain a disinfectant residual throughout the system at all times. It prevents bacteriological regrowth and development of taste and odors. And again, a large consideration of our water quality is the pipe material. We do an excellent job of treating the water. We can't forget, though, what happens once it leaves the treatment plant into the distribution system. Our turbidity leaving the treatment plants right now, typically less than 0.05 NTUs, color less than 1, iron less than 1 milligram per liter. Sometimes we have had circumstances where you get some flow reversals. One of the things that's tricky about the system I used to work in, we have many sources of water. We have water that we buy from the State Water Project. We have 2 different treatment plants. We also have a couple of well fields. So if all of a sudden you drop out a treatment plant and you turn on 35 million gallons of well production, you get these radical shifts in the distribution system. And that can stir up sediments, it can scour old iron mains or unlined steel, which we had a fair amount of in my day job. So nobody likes to see this coming out of their bathtub tap. And the great thing is that when you have to tell people, oh yes, the water is safe. Okay, you drink that. That was one of the cool things. Everybody remember Milwaukee? Anybody from Milwaukee? Good, okay. No one is a complete failure. If nothing else, you can serve as a bad example. Early day today, isn't it? Okay, so in Milwaukee, 400,000 people got sick from a failure in the drinking water system. 400,000. Cryptosporidiosis. Over 100 people died. And they kept saying, oh yeah, there's no problem with water, it's all fine. And finally, the mayor called his public works director and he said, any problem with the system? And he goes, oh no problem at all. And the mayor put a glass of water in front of him and said, drink it. He refused. Mayor fired him, brought in a new guy the next day, solved the problem. So other pipe materials that we have in our distribution system, I think in Fremont where I worked, we had all of these. We had asbestos concrete, we had mortar-lined steel, unlined steel, cast iron galvanized, we had HDPE, we had everything. And it seemed like everything was giving us problems, with the exception of, it was just, since we started this conversion to PVC in Livermore, we have not had a main break in Livermore on a PVC line. So some of the things that can cause water quality degradation, this is actually some mortar that we flushed out of a pumping L. There's of course rust. There is flow reduction due to tubercle formation. There was in another water agency, they actually had a cathodic protection system set up on their steel mains. I believe they were two 24-inch steel mains. They reversed the cathodic protection. Yeah, how many ways can that go bad? They had to replace 2 miles of 24-inch steel main because it was failing. Okay, we periodically do main flushing where you get fire flows, flow reversals. I collected the sample. This came out of somebody's faucet. Oh yes, the water's safe to drink. The iron's good for you. Well, it means that the water already looks like a latte. You're halfway there. Okay, here's one of my favorite shots. This is tubercle formation in iron pipe. So, yeah, a little bit of flow reduction, as you can see in that. By the way, that piece of pipe is 6 inches long. This is the difference between what iron looks like and what this is actually from elastomer degradation, the particle flex right there. One of the problems, since I'm talking about pipe materials that cause problems, this is elastomer degradation that's caused by chloramination. Now, a lot of us switched over to chloramines when we were going for trihalomethanes control, and we found out that does tend to break down the neoprene and rubber elastomers. So we would find that you would get these black particles, typically on the first draw of the water, and that was the degradation of this neoprene liner, so that people, again, they would get pretty excited about this. Also in water heaters, if you had the braided flex connections on the water heaters, you would end up with these black particles that would come out, and that was simply the elastomer degradation. Another sample of it there. Copper. So we had some instances where there was copper corrosion and we were getting blue water. Some of the interesting work that was coming out of Washington, D.C. with Mark Edwards is they found that there was, this was some of the copper lines in a town north of us. And it was the same cause of the lead contamination that was happening in Washington, D.C. about 6-7 years ago. What was happening is they were replacing the lead service lines, but they were cutting the lead at the property line rather than replacing the whole line. And when they did that, by cutting the lead, they created a new fresh lead surface. Well, because Washington, D.C. had switched over to chloramination, when the chloramine breaks down, it puts ammonia back into the water, or nitrates. Well, nitrifying bacteria use that as food. So the nitrifying bacteria start cranking away. The pH drops because of the addition of CO2 to the water. The water becomes more corrosive, and it was actually leaching the lead from the pipe. So it wasn't so much the chloramination, but the chloramine was causing the food, which then allowed the bacteria to grow. So it was related, but the conclusion was incorrect. But this is one of the things that we got. This was from biological corrosion of copper pipe. So again, one of the considerations for PVC, as I mentioned earlier, the installation ease, low cost, low maintenance, and the no degradation in water quality, which for us is very important. Additionally, the best management practices. Now, this is actually a whole other talk. When you talk about when you are installing PVC pipes and any installation, best management practices are absolutely critical. We require double checks or RPs before, and this came out yesterday, as a matter of fact, during the talk about requiring the double checks for the distribution system with the installation of PVC pipe. We require it because in case there is a problem with the installation, it doesn't get back into our system. Once it passes bacteriology analysis, then the RPs can be removed and it's tied into the entire system. The proper use of pipe soap, the joint compounder, what some people refer to as duct butter, when you're when you're joining the pipes together. What's very important is to ensure that you have sufficient main flushing prior to the disinfection, because that reduces the demand. If you've got a lot of junk in the pipe, it's going to use a lot of your chlorine for the chlorine demand. And of course, that's just money. You're throwing the money away. So you have to flush the pipes out to ensure good disinfection. And make sure that you have sufficient main flushing after disinfection, because that way you remove a lot of the taste and odors and sediment. This one was a real hassle. So this was installed. This would not pass back T. And of course, the developers coming in, they're blaming it on me. But we ultimately had to go into this section of installed pipe, dig it back up, pull this stuff apart, and found out, it confirmed what I suggested, is that the developer, instead of using the proper materials, the pipe soap or duct butter, we figured it was some sort of axle grease. I wonder why that won't pass the bacteriological analysis, right? It was just the wrong materials in the wrong application. And no amount of chlorine is going to resolve that. You can't make up with chlorine for bad work. This was a fun one. I actually collected this out of a toilet tank, of all things. And it was about that level. There was about this much of this gravel in the bottom of the toilet tank. What happened is when they installed the pipe, they dropped it into the ground, and it got this great big scoop of the cutback that the pipe was resting on. So when they charged the line, it wasn't properly flushed ahead of time, and when they finally connected the distribution system, and we got distribution system flows through the main, it scoured the line, picked up all of the cutback, and blew it right into this one building. So that was where all the sediment came from. Again, it wasn't properly flushed out before they put it into the system. Metal rods that this is actually from a cathodic protection system. It's good. Now, can you imagine if you're running a fire hydrant, you got a fire flow going on, and you're trying to put out a fire, and all of a sudden these things come up into the hydrant? This was, again, you need to have sufficient main flushing after the installation. Those are two 4x4s. More stuff that I flushed out of mains. And you thought they only lived in sewers. Yeah, that one came out of a hydrant as well. This was really interesting. This came out of somebody's faucet. Can anybody identify this? Okay, so this came out of somebody's faucet. The famous Marchand dime there is for perspective. Well, okay, so this came out of a fire hydrant. Okay, those are the turnings from a hot tap into a PVC line. So when you're drilling the corp stop into a PVC main, this is what comes out if you don't flush out the hydrant after the fact. They were trying to do some main flushing for a new installation, and they kept clogging up the screen on the blow off. And this is what it was. It was the PVC turnings from the hot taps.
Interesting.
Took me a while to figure that one out. Flint, Michigan, again, another bad example. As you all know by now, this was a hot topic at the U.S. Conference of Mayors back in January. I actually did the pilot testing for my water agency when we were doing the lead and copper analysis for our different water sources. Again, lead service lines, lack of corrosion controls, had they adjusted the pH, adjusted the phosphate addition, they wouldn't have had the problem. I already mentioned the Washington D.C. experience, but these are long-term health effects. And you know, the crazy thing is, first off, the governor says, your government failed you. Right. And so how do you rebuild the trust? And why did they do this? They were trying to save money. Now, how much money do you think they saved in the long run? This is going to cost them millions. And that's not even counting the lawsuits. And the loss in consumer confidence is incalculable. So it just pays to do it right, because if you don't have time to do it right, how will you ever have time to go back and do it over again? And again, you will never restore your confidence. Just a shameless plug for the U.S. Conference of Mayors here. We share best practices, and a lot of the folks here in the mayors in the U.S. Conference of Mayors, we all do the same thing, but we share best practices. I share my experience with the PVC pipe. One of the mayors was talking about a problem that they were having. They were getting these sporadic foul odors throughout the distribution system. They would go out there, they couldn't figure it. They were checking the water sources, water treatment. They were all set to hire a consultant for I think about $20,000 to find out where the odors were coming from. And he brought this up during the meeting. And I said, excuse me, I said, let's talk afterwards. In 5 minutes, I explained to him that the foul odors were not coming from the water. They weren't coming from the mains. They were actually coming from the P-trap.
Right.
So all I have to do is get a little bit of hot chlorinated water, flush it down through the sink, and the problem goes away. A couple years ago, my wife comes up to me and she says, John, the water stinks. And I says, Sue, the water can't stink. I'm a water chemist, right? And it turned out what was happening is it was coming from the dishwasher line. What was happening is as the garbage disposal would fill up, and then the garbage would back up down into this line in the dishwasher. And if you didn't run the dishwasher frequently, that would rot. And then when you turned on the garbage disposal and turned on the water, it would displace the water back up through this drain, and you get these foul odors coming out of the vacuum breaker. So, in one meeting in 5 minutes, I saved one of the mayors in Texas $20,000. So, sharing best management practices, that's why we work together. That's why we collaborate, and that's what this membership's all about. So, I certainly appreciate the PVC Pipe Association and your membership in the Conference of Mayors. It's well worth it. So, with that, any questions? Actually, this is funnier because I used to be a marine biologist, and there actually was an animal called a sea cow. So when I said this, I thought it was hysterical. You guys maybe not so much. But, any questions? No questions? Very good. Thank you very much.
Okay. Our next speaker is Willaim Spickelmire. He's a corrosion expert, and he's going to talk. You have to wait for your song. I'm sorry. He's going to talk to us about corrosion. So go ahead.
I'm working so hard, I'm punching my car. Here, over, oh, tell me what I got this clear, top to the hole and the tree down.
Well,
Didn't know I had a song, I guess. I'd like to talk today about corrosion control considerations for ductile iron pipe. It's one of the most controversial subjects that we have in the industry from a corrosion standpoint, because at times it is a market differential between different pipe types.